Go. Hello, everyone. This is Dr. Posset Faroo and the Meta-Analysis Program. We're back again, and this is class number 1. And we are just pointing out what is the meta-analysis, what are the differences between systematic review and a meta-analysis. We choose to do the analysis of the statistical data and the statistical data extraction from the papers, a certain software to work on, which is the review manager based on the Cochrane.org. Cochrane, it is one of the best websites dealing with this statistical meta-analysis. And also we teach you here all the program of this meta-analysis. It's based on the undertaking meta-analysis of the handbook of Cochrane. I will send you the handbook of Cochrane. This is very important to have it with you as a source. This is the source, and this is the textbook. Of course, if you can read it, this is excellent. If you can't read it, we are here to explain it for you. And you must have this as a reference for you later on, even after we finish the course, you will need to go back to certain data, go back to clarify something or anything. Now let me tell you something, a very good example about meta-analysis. Suppose that I'm going to start again from the beginning with you I will choose a topic and I will start to see what are the steps of implementation of meta-analysis step by step. My topic is effectiveness of RTPA in acute cerebrovascular stroke. Acute, hyperacute ischemic cerebrovascular stroke and use of thrombolysis in this stroke. So this is my broad idea and this is the first topic I will start with. So now, what studies should I collect to do a meta-analysis? Now I'm starting a topic from the beginning to do it as a meta-analysis formatting, not as a traditional review, not as a scooping review, not as a systematic review, as a meta-analysis. So now, what studies should be collected? I hope that others will follow. What studies should be collected? I have to collect randomized clinical trials, which is recent, which is updated, which is relevant. Randomized clinical trials, peer-reviewed in English language. So this will be my choice. Only RCTs. Yes, Rashida, you are right. So studies will be RCTs, peer-reviewed, published, completed, in English language, recent, relevant, in the last 5 years. Number 2, what comparison should be made? So the first question, you should ask for yourself, what comparison should be made? So this comparison is mandatory? Yes. To do a meta-analysis means you must collect a randomized clinical trial and you must create comparison for that. What comparison? I will compare cases with acute cerebrovascular stroke, receive thrombolysis versus another group of acute cerebrovascular ischemic cases receiving placebo. This placebo, it could be heparin, it could be low molecular weight heparin, Clexane, Fraxiparine, aspirin, anything but not RTPA. So this comparison, I am having now the two groups and I'm having the intervention. So cases with acute cerebrovascular stroke receiving TPA and cases of acute cerebrovascular stroke receive placebo. So in every study, I should collect the study who have the two arms inside. So if one study, it's writing a very amazing words about the RTPA and a very amazing explanation and a comprehensive review about RTPA, but it did not include these two arms. Can I collect it? No, it is not fitting for a meta-analysis. It's fitting for any other type of study design. I will compare between these two arms in mortality rate. in survival rate, in need of ICU admission, in reperfusion hemorrhage, in days of hospitalization, in functional recovery. All these could be a comparison, could be made between these two groups. Again, anyone who just Raman who just
I think I missed the things, like, what did you say?
again, Aditi, sorry.
I think I missed some points because I didn't notice like you sent the link.
Okay, no problem, no problem. So here, Aditi, we are talking now, we are just giving an example about effectiveness of, this is my topic, as if I'm choosing this topic to start a meta-analysis from the beginning. So what are the steps that I should proceed step by step? Number one, I choose a topic which is the effectiveness of RTPA in acute ischemic cerebrovascular stroke hyperacute cases. So the question number one, you should ask yourself, what studies should be collected? We agreed on, we will collect RCTs only, recent, relevant, in the last 5 years, in English language, peer-reviewed. What comparison should be made? I will compare between two groups. One group of acute ischemic stroke receiving RTPA and one group of acute ischemic stroke receiving placebo. The comparison should be made between both groups in survival rate or mortality rate or need for ICU admission or need for mechanical ventilation or days of hospitalization or functional improvement, functional recovery, reperfusion hemorrhage, safety profile, efficacy profile, or whatever. Which study results should be used in meta-analysis? Suppose that you choose mortality rate. You are now comparing what comparison you should make. I compare between mortality rate, between these two arms. You agree that I should have two arms. What outcome measure I will look for to pick it up from the results section? I will look for mortality rate. And this mortality rate, if I put in my inclusion criteria, I will compare mortality rate after 1 month. So I should collect all the collected studies should have this comparison and this outcome mentioned with quantitative numbers inside the article. If I'm collecting a very good article about RTPA and it is an RCT, but it's not measuring mortality rate after 1 month, so I cannot include it. Okay, so I'm talking about mortality rate after 1 month, which is mortality rate after 30 days. I can collect mortality rate after 30 days, mortality rate after 28 days. This is pooled studies. I will collect all the studies which have this outcome. Can I collect articles which deal with no mortality rate? No. Can I collect articles which having mortality rate after 3 months? No, I cannot collect it with these studies, with this pooled collection of studies. Otherwise, they call it here in the meta-analysis, you are collecting apples with oranges. You are collecting apples with oranges and you call it fruits. We are not making a fruit salad. The same outcome and the same comparison you are picking, you should stick to this. Mortality rate after 1 month, so all of the collected studies should have this mortality rate after 1 month quantitative data. If it talk about, if a good study and it talk about mortality rate after 1 month, but I cannot find numbers, I cannot find tables, I cannot find, there should be a table, comparison, two arms, numbers of cases included, who sample size in this arm and sample size in this arm, and those who died after 1 month in this arm and those who died after 1 month in this arm. If this is not present, so you cannot include this in your meta-analysis. Like you have one arm with acute ischemic stroke receive TPA. This arm it is composed of 80 participants, and another arm with acute cerebrovascular stroke receiving no TPA. And they are 95 participants, and numbers are present inside the study. That here 11 died and here 21 died. In such case, I can include it. Okay? 4. What is the best summary of effect size used in all studies? What's meant by the effect size? Effect size, this is the way we measure this comparison between both. We will have a separate day, a separate class, talking only about effect size, what is the odds ratio, what is the risk ratio. But in quick brief now, as an introduction today, you should know that if you have these numbers, I'm having the total sample size and I'm having those who died after 1 month. And on the other arm, I'm having the total sample size and those who died after 1 month, then I can create the odds ratio or risk ratio. We will see how can we do it together. How reliable are those summaries? Studies comparing healthcare interventions, notably randomized trials, use the outcome of participants to compare the effect of different interventions. So I'm comparing now the effect of 2 interventions. The meta-analysis, it focused on a pairwise comparison of intervention, such as experimental intervention versus a control intervention. One group will receive the experimental intervention, which is here the RTPA, and one group will receive the control arm. The main example you have to put in your mind to do a meta-analysis, like the main common example, which is the effectiveness of a certain drug testing in 2 arms, measuring or testing the efficacy of a certain drug in a certain disease versus placebo or versus a control arm. Okay? Terminology used here, experimental versus control intervention. This is the basic, this is the classical way. The contrast between the outcomes of 2 groups treated differently is known as the effect. The contrast between outcomes of 2 groups. They treated differently. One of them received the intervention, one don't receive the intervention. This is the effect size, or the treatment effect, or the intervention effect. Whether the analysis of included studies is narrative or quantitative, narrative in a traditional review form or a descriptive qualitative in a systematic review form or a quantitative in a meta-analysis form, a general framework for the synthesis may be provided by considering 3 questions. What is the direction of effect? And what are the size of effect? Is this effect consistent across studies? What is this effect? Effect, I mean the effect of the contrast between the outcome between 2 arms. So again, to our example, we are talking about mortality rate numbers in these 2 arms. What are the direction of the effect means that who have less number of mortality? Those who receive the RTPA group or those who don't receive RTPA group but receive only heparin? What are the size of this effect? Is it big or small? We will see this now. A major problem of meta-analysis is that they combine apples with oranges. Studies are clinically diverse. Then a meta-analysis, if you collect studies which are clinically diverse, then a meta-analysis may be of value, of no value. Like if you are collecting studies dealing with survival analysis and survival rate, with mortality rate after 1 month, with mortality rate after, together with another studies dealing with mortality rate after 28 days, and mortality rate after 3 months, and mortality rate after 6 months. Then you are collecting apples with oranges. And it will lead to this intervention will be very diverse. This will be totally misleading and this will be of no value. A big bias here happening and the results will be misleading. Now, let's go on with how to do the meta-analysis step by step. You should choose a good topic. Formulate a research question. Specify your pairwise comparison that will be made. So now, what is mandatory that we have learned today? PICO research question is a must. Predefined inclusion-exclusion criteria is a must. Pairwise comparison is a must. To do a meta-analysis means you should have a pairwise comparison. It is a must. You should have two arms, two groups, one group having intervention and one having control, and a comparison made between both. A decision about which studies, which is the RCTs, are similar enough to be grouped together in data collection. The same consideration apply to deciding which comparisons to make, which outcome to combine, and which key characteristics of the study design, of the participant intervention, of the outcomes to consider when investigating variation in effects. This will lead to heterogeneity. We'll talk about heterogeneity later on. We will explain everything about this step by step. This consideration must be addressed when setting up the data tables and analysis tables. Types of data are very important, but I will skip it today because I need to show you something important and we will talk about that next time. You remember now the example I was talking about of the RTPA and randomized clinical trials. Now, all of you, please look to this figure, to this slide. This is very important. If you look for this, you will understand exactly what I'm talking about. This is the meta-analysis. And this will be the meta-analysis that you will end up with. And this is the meta-analysis that you will create independently by yourself, alone, by the end of this course. You will be able to do it by the end of this course using Revman and our program. This is the graphical representation of the meta-analysis. We call it forest plot. Rashida know that. And here we are discussing what? Seizure recurrence. Yes, Rashid. I am now looking for seizure recurrence, and my comparison I'm having here I can see the question or the chat. Okay. So we are having here a topic about seizure recurrence. I'm questioning the seizure recurrence. My research question and my research problem, it's about how many times you can have seizure recurrence including 1, 2, 3, 4, 5. 5 studies. You included 5 studies in this forest plot. And you are having 2 groups and 2 arms. One group of participants, maybe children, receiving corticosteroids, claiming that corticosteroids will reduce the number of seizure recurrence. And another group of children who are epileptic, who receive the usual treatment of anti-epileptics, putting them in the control arm. So now we are having 2 groups. One epileptic children receiving corticosteroid as my experimental intervention, and one another group control arm receiving the usual anti-epileptic. And I am checking these numbers. What are the total sample size? What are the number of children who are having seizure recurrence? So in the study 2006, I'm having 30 total number of participants receiving corticosteroids. And can you hear me clearly?
Yes.
Okay. And the control arm having another 30 participants receiving the control arm. 4 out of 30 having seizure recurrence in the group having corticosteroids, and 14 out of 30 experienced seizure recurrence in the other arm. And in the second study, we are having 47 sample size, 5 out of 47 have seizure recurrence, and 45 on the control arm. And this happens in the 5 studies. We have to extract this from the study. If these numbers are not present in the study you have collected, so it is useless. I cannot get use of this study to create a meta-analysis. The other numbers in the figure in front of you, it will be created for you automatically by the software, which is the RevMan. Okay? As a conclusion, every study, it is represented as a horizontal line. We will discuss that in details as we move on with the course. This forest plot have a separate class. But at the end, I need to have a conclusion from all these pooled studies, not one by one study. This overall effect of the conclusion of the outcome of the pooled studies, it is denoted by this diamond shape. If this diamond shape falls here, so it favors corticosteroid. So corticosteroid is the winner. So corticosteroid is the better. So corticosteroid prove its efficacy to reduce seizure recurrence. If the diamond shape falls here, this means that the control arm or the regular anti-epileptic are the winner who are having less number of recurrence. If it crosses the line, if this diamond shape crosses the line, then corticosteroid equal to the control arm, and this intervention is of no value. And this meta-analysis, it is not of any statistical significance. So I need all of you to know that meta-analysis, it is a one step more than systematic review. Meta-analysis is different than systematic review. The way that you prepare yourself to create a meta-analysis is different from systematic review. Meta-analysis, you should choose a certain topic that work as a meta-analysis formatting. It should be RCT, there should be an intervention. PICO is a must, and you should collect the best studies that you can, which have fulfilled your pairwise comparison. What's meant by pairwise comparison? The comparison that you created between the two arms. Suppose that you are creating a mortality rate in this group or this group, survival rate, anything. So if I collected one good study about the same topic, but this study do not include these two arms, what to do? You cannot use it in a meta-analysis. If it have these two arms, but it did not include numbers, what to do? It cannot be used in our meta-analysis because we cannot conclude number. We cannot assume numbers. Numbers, it should be present, exactly mentioned in the study in your hand. After that, the rest of the graph, the rest of this statistical analysis, we will learn it step by step. We will move, as we move through the course, we will learn how to work with this. You will be able to download the review manager on your laptop and work independently with me in live classes, hands-on on the review manager to create your analysis. And at the end, you will be able to do it independently by yourself. This was today's class. I hope that this was clear and simple for all of you. Do you have any questions before I go?
Yes, ma'am.
Yes.
The randomized withdrawal study can be added
Can be added to what?
in a meta-analysis.
Yes, this is what I'm saying from the beginning. Randomized controlled
Randomized.
trial. This is the only one that can be added.
Now,
Not the
I'm
only
just
one.
asking randomized withdrawal.
Randomized
Withdrawal study.
What is the randomized withdrawal study?
So they have like randomized control now. The withdrawal came in, means like they came from like randomized control trial, and they're comparing for the efficacy and everything.
Randomized control studies?
So they went for the randomized control studies, the
Yeah.
participants. Then after that, finishing of this control studies, then they come back for the that is called the withdrawal, because they come back from the randomized control. Now
Withdraw.
they are for the follow-up things.
Withdraw.
Yes.
Yes, yes. It can be added if it is if it have the numbers, if it have a good tables and a good data.
Okay, ma'am. I collected some studies for the systematic review and the meta-analysis.
Yes.
If you can actually see the studies, I can send you.
Yes, I will send my email for all of you. Yeah, and we will keep in contact, all of us, after the class and all the week. You can text me, you can send me whatever you feel like, and we will answer all the questions. We will continue communication all through the week. Send to my email. I will be happy to receive all your questions and concerns through the chat
Yes.
of the WhatsApp group or through my email.
Yes,
Send
thank
it
you,
to
ma'am.
me
So
again.
that I can actually make sure that what are the topics I choose and the studies that will be okay for this. Okay.
Okay, I will be happy to do this with you. Send it for me. Rashida says that I used Gmovie software for the meta. Okay, yes, it can use, of course, for the meta-analysis. What type of meta-analysis did you complete, Rashida? Pairwise? Okay, yes. But here we will do it with Revman. Revman is more easy. It is for free and it is easily downloadable from Google. And also Revman, it can work on Windows and Mac, because those who are having Mac, those Mac guys are always having problem with this software. So the Revman, you already downloaded Revman? Excellent. Excellent. And we can also learn about this Gmovie from you. So Revman, it's freely downloaded. You download Revman, you mean that? Yeah, excellent. It was easy for you, right? Are you Windows or Mac? Of course, all of you have to download it. I will send you the link on the WhatsApp. You have to download it on the laptop. Don't try on the phone or on the tablet. Laptop or PC. Okay, it will be it work only on laptop or PC. So great, great. You already downloaded. This is great. You can see it's easy and free and nice. We will keep contact with each other. But today's class is finished. I hope that it was clear for all of you. I will be happy to receive your questions any time of the week. And thank you and goodbye for now. Have a nice day, all of you. You will receive the recording through a Google Drive link in the WhatsApp. Any
Thank you.
questions before I go?
Just one question. Should we include gray literature?
Should we include what?
Gray literature.
No, here, no. You can include gray literature in a systematic review paper. In meta-analysis, how can you include it? No.
Oh, thank you very much. That answers my question.
Yes, you are welcome. Thank you and have a nice day, everyone. Goodbye for now.